scale out your compute and storage is necessary. Want to quickly spin up clusters? Since everything is done by software, it's a matter of minutes, not weeks. All about moving resources between clusters. No problem. So long, silos. Want to upgrade to a new processor? Replace your servers without replacing your disks. Server failure? Just recompose its disks with a new server, and you're back in business. Best of all, industry standard servers and storage you know and love. No changes are required to the application stack, and performance is equivalent to servers with internal drives. With DriveScale, the inflexibility of scale-out is ancient history. Visit drivescale.com to learn how you can optimize infrastructure for your big data workloads.
We have sales agents standing by. So DriveScale has a bunch of old farts like myself. We've been around the enterprise computing business for a long time. We're mostly ex-Sun people. Gene Bandman's our CEO. He ran the entire Sun workstation business for a while. My co-founder Satya designed many generations of workstations at Sun. We were both at Nuova Systems, which became the Cisco UCS server business. Satya designed many generations of Cisco UCS servers. And he's very well known in the Valley. A lot of great advisors, including Whit Diffie, inventor of public key cryptography, and another Sun buddy. So we have chops. So what are we all about? We're all about looking at this growing data, and this is the IDC chart everyone's using. You know, it's exponential, and exponentials are a dangerous thing. We believe that the traditional workloads that people are running with VMware and SANs are really not where the growth is happening. It's really the new workloads like Hadoop and NoSQL, all those kinds of things that are driving the real growth of data. And those are all deployed as scale-out clusters. None of them like to use SAN or NAS because SAN and NAS are just too expensive and too slow. So the data center needs a transition of architectures. People who were happily running virtual machines with shared SAN find that the demands of these new scale-out things just don't fit that architecture anymore. And so they start buying clusters of servers, but each of the servers has to be different for each type of cluster, and that's not a good thing. So the fixed ratio of compute to storage is bad. The coupling of the life cycle of compute and storage is bad. And it just makes it very cumbersome to do anything in the data center once you get to hundreds and thousands of scale-out nodes. So DriveScale is 95% about being a software company that manages the composability of all these hardware resources. So we're very close to the hardware, but we work with pretty much anyone else's hardware. And we support the scale-out technologies on top. We started with Hadoop. It's a big market for hard drive-based things, but we're spreading into lots of other things. We have a complete plugin for Kubernetes that works with our stuff. We work with any kind of server, so the customer has total choice of what kind of server to use. But it makes sense now to use smaller, denser servers with our stuff because you don't have to put as much stuff in the server. Today, we're doing mostly Ethernet-based things with iSCSI on top to talk to hard drives, but we'll have a product out very shortly leveraging NVMe over fabrics, where that's appropriate for SSDs. Some of our competitors are already doing the PCI Express-based thing. We're kind of agnostic about the overall data path, but we think Ethernet is the right place to start. But ultimately, you can imagine every type of hardware resource being composable, all the way from the servers themselves to GPUs, FPGA accelerators, that kind of stuff. So again, it's two simple steps. We call this the two parts of the magic trick. The first part is you cut the lady in half. You separate the resources. And that's the easy part. The hard part is putting her back together and making it make sense. And that's the composition part. So instead of buying the servers with the internal storage, you buy racks that now have diskless servers or disk-lite servers. You know, usually they're still going to have boot disks, because those are, it's a whole different problem getting rid of the boot disk. And then you buy drives in JBODs. How many people know what a JBOD is? All right, very good. But basically it's a chassis full of hard drives, and we're talking dumb JBODs that have no processing whatsoever in them. So really, it's a very cheap overhead for the drives. The JBODs speak SAS protocol, serial SCSI, because that's what the drives speak. And SAS is awkward as a networking technology, so you don't want to plug that into every server. Oops, it's on a timer loop. Come back. So we built a thing we call the drive scale adapter, which is a very fast, very cheap piece of hardware which does SAS to Ethernet conversion. And basically it speaks iSCSI on one side, on Ethernet, and SAS on the other. It has exactly 0 SAN services in it.
Is that per drive?
Yeah, so each drive becomes a separate entity on the network.
We did that years ago.
Yeah, and it's not a hard thing to do, right? But it didn't really exist in the industry. So you put things together now. So here's an example. You know, the yellow server gets a bunch of yellow drives. And the great thing with our software is you don't have to know which server or which drives. You just say, I want a server with so many drives, and it'll find one and attach drives from the same rack so that the bandwidth is there, and let you do your thing. And so now you can have different types of servers that physically are all the same but are used for different clusters. And you span your clusters across your racks, and the cluster is no longer a physical thing, it's a logical thing within your hardware pool. Okay. So our product has a number of components. So we have an agent that lives on every server that sets up the connections to the other resources. What is going on? I think there's a timer thing. And there's a management system which keeps the central inventory, and then the making me crazy here. And then we have a web service, DriveScale Central, which you can upload logs and download software, that kind of thing.
Call home?
What's that?
Call home service or?
I'm sorry, I couldn't.
Call home?
Yeah, call that type of service. So we have, in the product today, we have this DriveScale adapter. It's a 1U box. I'll have another slide on that. And it talks to the JBOD. It's typically one-to-one with a high-density JBOD, but if you have colder storage, you can have more JBODs per adapter, or the reverse. And then soon we'll be releasing the software that deals with JBOFs, or EBOFs, depending on what you call them, but boxes full of flash that speak NVMe over fabrics. So the DriveScale adapter, again, it's a 1U box. There's actually 4 separate adapter cards in it. So it's like a networking piece of networking equipment with 4 blades. Each blade does 20 gigabits of throughput from Ethernet to SAS. And so it's 80 gig for the whole box. And because it's highly redundant, you can have very highly redundant paths to all the storage. And it's really really cheap and really low power. Does not use an x86, uses a network processor.
Is that, does that have to be configured by the customer, or is it just a generic thing you can slap a replacement in?
It's, you have to give it IP address, basically. That's about it. and then our software takes care of the rest. We automatically discover what switches are plugged into which servers and which adapters. Based on that, we know who's in the same rack. We can allocate storage in the same rack as the server. And we have, well, how many people have ever set up iSCSI on Linux? And how many people enjoyed it? It's like, yeah, a couple of. Anyway, people usually don't want to go there. So we hide all of that from our users. We completely control the iSCSI setup on both ends. We completely control multipathing, so you can have as many paths as are possible. And there's, in many cases, there's 8 or 16 paths now between the drive and the server.
So does the drive scale adapter manage all the individual hard drives? We add another hard drive, does it automatically allocate it? Does it, you configure you put the configuration directly in the drive scale?
Yeah, so the hardware resources are all discovered and put into our drive scale management system. And from the management system, you say what kind of servers need what kind of storage. And you do that at cluster scale, so you can allocate a whole bunch of identical servers at once.
Pluggable?
Uh-huh.
Hot plug?
Yeah, pull the drive, put in a new drive, it shows up immediately.
That's just the SAS JBOD functionality. That's not you.
Well, we have to carry the discovery up to the management system. Right. And we do a fair amount of hardware level management. So you can see when the drives are getting smart errors independently of what's going on in the server, that kind of stuff.
So that's a great point. Where are the smart errors discovered?
They're discovered in this adapter. And the server can also discover it if it wants to, because it's a straight raw SCSI connection. But we report it from the adapter to the central management.
Those adapters are just SAS,
Yeah, it's really, really dumb.
HBA.
Yeah,
SAS HBA.
yeah. And our philosophy is if you want fancy storage software, like what you get from a SAN, then you should do it on the server side, because SANs are just servers anyway these days. There's no such thing as storage hardware anymore. There's storage media, but the SAN systems are just software and servers.
So you call that entire enclosure the adapter?
Just, yeah, the box is the adapter, yeah. So,
Are the individual hard drives on the SAS backplane?
yeah, so the JBOD provides a SAS backplane.
Okay. We did something slightly different, so we had the adapters directly to the drives. Right? So
Okay.
the adapter on the drive.
Yeah, I've seen those.
SAS backplane.
So our friends at HGST just loaned me one of their new JBODs to test. It's 102 drives in a 4U package. And the drives are 12 terabytes. It's like, here, try one of these. So it's a 1.2 petabytes. You know, like, that's the new unit of storage. So summing up, we think composable infrastructure is the way to go. It's better than DAS because you get a lot more flexibility. It's way better than SAN or NAS because it's much more performant and a lot cheaper. We're not selling you we only sell you the software and the adapter. You buy the JBODs and the servers from your favorite vendors, and all the server vendors have JBODs except Cisco. But we have a different solution there.
But you qualified some number of JBODs,
Yes.
so you
So-
can't just say open season on JBODs. I mean, there's
Um,
too many.
We've never found one that doesn't work. We found a lot where the manageability leaves a lot to be desired. So it's basically how many features do you want.
So when I go on the AWS and put it in the server, is it using this technology or similar?
We believe AWS uses something similar to this underneath their S3 and EBS services. But we don't know exactly what they're doing. Google does not use this kind of thing as far as we know. But. So we like to say we do for clusters what VMware did for servers. Because it used to be that every server was a different physical instance running a specific application, and the server was configured for that application. People are now in the same situation with clusters, where all the clusters are physically separate, and each is physically different. That's a very bad thing. So we help you consolidate all that into a single hardware pool that's very dynamic. And that's it. Any more questions?
So for physical drive, it probably doesn't matter, but I'm wondering about SSD storage, latency versus in the box versus across your platform.
Right. So yeah, for hard drives, it doesn't matter much at all. For the NVMe latency, NVMe over fabrics, we've measured between 5 and 15 microseconds of overhead for going out of the box if you're using RDMA. There's a lot of reasons why you shouldn't use RDMA, and then it's much higher penalty with iSCSI. But still, Samsung did this paper where they compared the two, and if you're only reading, you notice the iSCSI latency a lot because reads are fast. As soon as you start writing, it slows everything down so much that you don't notice iSCSI latency. And so we think a lot of people will still use iSCSI. And our software will support whatever you want.
For the home infrastructure, are the adapters also are able to be part of another adapter, or could be one?
Yeah, the adapter doesn't do much. Its job is to put the drives on as network entities, and now they're all independent. So when you assign drives to a server, you might be getting drives from any of the JBODs in the rack. It doesn't matter.
So each rack is individual, and you can't
Yeah.
overlap
Well,
one rack to another?
we recommend keeping it in the rack because you need a lot of bandwidth if you're doing analytics. And what happens is most people overcommit the network coming out of the rack. 4-to-1 oversubscription is very common. That means there's a whole lot of bandwidth left in the rack that's available. So we can do our whole trick without ever affecting the backbone traffic at all.
So the composition is within the rack, clusters, workloads.
Yeah, the management is across the whole data center. So you don't have to think about where things are. It just assigns the most appropriate. And then if you really want to separate the storage, we have one customer who has a rack of all servers and then a rack of all drives. And that way he can swap out the server racks much more frequently than the drive racks. And we worked with him to make sure there's plenty of bandwidth between the two. Paul?
You said there's lots of reasons why not to use RDMA. Can you say some more about that?
There's no such thing as congestion control in RDMA. So you can get strange congestion spreading in a large network where one slow device locks up completely unrelated things. It's very weak on availability. So what do you call it? I'm blanking out here. The thing where you have multiple Ethernet links for high availability. Yeah. Link aggregation, yeah. That sometimes works with RDMA and sometimes doesn't, and you can't have link aggregation across two different RDMA NICs because there's too much knowledge in the NIC. And so there's just a lot of rough edges for RDMA.
But it sounds like you're talking about Rocky V1. If you move it up to V2, which is all IP based.
It's all IP based, but it's still in the NIC.
Yeah.
And so the NIC has to be aware of everything. So if you have two NICs, it doesn't work right. And
But you could fix, anyway, I can talk to you about that.
Yeah.
You could fix some of that in your adapter.
and we do fix kind of at the multipath level some of that. But we keep discovering more and more bad things about RDMA. Mark?
Are you coordinating between the?
So that's an optional feature. So what we what we can do is configure the Linux-based decrypt on the drives so that the encryption happens on the server and it'll happen for all the data on the drive. And a side effect is the data going over the wire is now also encrypted. And we found that to be pretty low overhead for the server. And we have a whole key management system that makes it very simple to do that. So you basically, again, at the cluster level, you say, I want to encrypt all my drives, and you get unique keys per drive, and yet enough intelligence that you can move a drive from one server to another in the same cluster, and it'll understand how to get the key. If you try to use the drive in a different cluster, you can't use it.
And if you lose one of the encrypted data, one of the drives with the encrypted data that was encrypted on the server?
Well, it's just like any other drive failure. So
you're not encrypting the data on the drive. You already encrypted it in the server.
you encrypt it in the server, and the back end is unaware that it's encrypted or not encrypted. Yeah. But
so if there's if some customer insists on secure erasing drives and whatnot, that's separate completely.
Well, that's separate, but you really get the same benefits of the self-encrypting drives, but without paying extra for the drives. You pay extra for some CPU overhead.
So what kind of networking guarantees do you get between the servers and the drive? No packet loss, in-order delivery, etc.?
We use vanilla TCP/IP, and you don't get the guarantees. It's just high probability. So usually we don't see any issues. We use jumbo packets, but we can push the wire rates pretty easily.
Have you ever done any analysis versus, has it ever been the case that some level of protection on the drives level, a layer of, say, simple RAID protection, so that the upper layer doesn't notice as many failures as it could potentially notice? So have you done that analysis? What's the outcome?
Well, our typical target is that we run underneath something like Hadoop or Cassandra, and they're already doing replication and error checking, so nothing that we do at our level is going to help those applications. We have another feature for the more traditional applications where you can turn on RAID, again, on the server side. So software RAID in Linux, and we make that easy to turn on, so you can do it there if you want to.
So you basically, currently you don't offer any type of protection for the applications from this failure?
No, because our application is really a storage-aware replicating thing, right? So.
So are there any maximums? What's cluster size maximum? How many nodes or how many disks?
No serious maximums. We've tested our management system, through fake means, up to 10,000 servers and 100,000 drives.
And you need a separate infrastructure for your management?
Yeah, so the management system is actually based on Zookeeper, if you're familiar.
Okay.
And so you can triple replicate it to make sure it's highly available. And most of the communication to the agents is done through Zookeeper.
Don, if I have RAID and stuff on the JBoss, can I build RAID schemes of different kinds in this architecture?
Only on the server side. So software RAID on the server. And again, we do that so that you get full performance transparency. Because if you set up RAID, it might help IOPS and hurt bandwidth or something like that. And it's just hard to tell what you're getting now with a virtualized storage system. Anything else? Thank you very much.
Thank you very much for showing up. Thanks Ken and Tom online for the great talk. And hope to see you next month. We have details for your coming, so check the website for updates on that. There's more details right tomorrow. Thanks for coming.
So,